Hi everyone. Today I am going to discuss about the three questions related to the spring, block and pulley problems. These questions I am going to explain by using the energy method. These questions I have taken from the Pathfinder book from the Newton's laws of motion. As per the given question, in the arrangement shown, the springs are light and have stiffness K1 100 Newton per meter and K2 is 200 Newton per meter, and the pulleys are ideal. And 8 kg block is suspended. You can see here 8 kg block is suspended from the lower pulley is initially held at rest, maintaining the strings straight and springs relaxed. Now, the force supporting the block is gradually reduced to zero. How far does the block descend during the process of reduction of the force? Acceleration due to gravity is 10 meter per second square. Now, I am going to explain this same question by using the energy method. Just I am giving first concept for this. What concept I am going to use is energy method. Energy stored in spring is that energy stored in spring. That method I am giving. Okay, how this method will be there, you see here. You know that energy stored in spring is half into k into x square. Just I am multiplying and dividing with k by k into k x square. This can be written as kx whole square divided by the 2k. This kx square, I am taking this as, suppose there is a spring having spring constant k and it is connected to a block of mass m, and tension in the spring is T, and whatever the weight of the body is, let us consider the mg. Okay, now this T value I am taking as kx. This is the T square divided by the 2k. Suppose there are multiple springs like this K1, K2, like this different springs are there connected to the pulleys and connected to the single block. See here, single block. In that case, we can use this energy method to solve the problem. Okay, for multiple springs and pulleys connected to single mass m. In that case, I am writing like a summation of T square divided by the 2k value can be written as the tension force acting on the block T0 square divided by the, I can write the 2k effective. Here T is tension in individual springs. And T0 is tension force on block of mass m connected to equivalent spring. Okay, so here meaning of T square by 2k is nothing but T1 square by 2k1 plus T2 square by 2k2 plus so on, that is equal to T0 square divided by the 2k effective. Here in this case T0 value is this is the T0 here. Okay, now if you want to calculate what is the elongation or displacement of the block, to find displacement of block due to an external force, like that external force may be weight, may be applied force, etc. In that case, that extension or displacement can be written as F applied, so external force I am writing F divided by the whatever the K effective value is there, that K effective value we are calculating from this relation now. That relation we have to use here, this K effective value how to use. Okay, kindly keep in your mind how to proceed these kind of questions. Why I am proceeding this one now? I can do the by using constraint relations also, same problem, but problem is sometimes you may feel difficulty. So if block is moved by some displacement x, how much displacement elongation in the spring 1 and spring 2, you may feel difficulty. Okay, and one more thing is this finding K effective value, time period of oscillations in the for small oscillations of the block in oscillation chapter also, this kind of K effective methods we can apply. Okay, now I am going to explain this question detailedly. You can see here. Okay, as per the question you can see that K1 values and K2 values are given. I am drawing the diagram. In the next page I am going to draw this diagram. You can see I am taking this same question and I will paste in another page and I will do it again here. Look here. As per the question, there are the springs. How these springs are there? I am taking, this is one spring connected to the K1 spring connected to the support. Now this pulley is connected to the another pulley and it is connected to the another spring. We can see here another spring is there. This spring is having stiffness constant is K2. Now the whole arrangement is connected to the block of mass M. Now first I am giving the what are the tensions in the springs. The tension in the first K1 spring is T. As you know that pulley is massless, P1 pulley is massless, we can write it as 2T. So entire spring will have the same 2T. Okay. Now again pulley P2 also massless, we can write it as 2T plus 2T is 4T. Now as per our question, this is our T1. Okay, this is our T2 is T2 is equal to 2T and our T0 is this, and whatever external force is there, that is mg, that value is equal to F. You observe carefully how far does the block descend during the process of reduction of the force, that they are actually giving this. Okay, now we are going to replace this into the single block system. We can write here like this: single spring having K effective connected to a block of mass M. Okay, I am using our general process. What is our process? T1 square by 2K1 plus T2 square divided by the 2K2. Two springs are there, I have written, and T0 square divided by the 2K effective. T1 square value is T square divided by the 2K1 plus T2 square value is 2T whole square divided by the 2K2. That value is equal to you can see that T0 and T and 2T and 2T is 4T here. 4T whole square divided by the 2K effective. We can see here everywhere the 2 term is there, we can cancel the 2 term, and everywhere T term also there, T term also get cancelled. If T term is cancelled, we can write as 1 by K1 plus 4 by K2 is equal to 16 divided by the K effective. In any problem, if they ask you to calculate the angular frequency, you can write it as omega is equal to root over whatever the value is there, K divided by the K effective divided by the M, you can write. If they ask you calculate the time period of oscillations, we can use the T is equal to 2 pi by omega. If it is asked in oscillation chapter, you can see this. Okay. Next one, you observe this 1 by K1 value. If you see that K1 is 100 Newton per meter, K2 is equal to 200 Newton per meter. I am writing here 100 plus 400 divided by the 200 is equal to 16 divided by the K effective. Now you can write the value is this is 2 times get cancelled, it is 100. So overall I can write it as 3 by 100 is equal to 16 by K effective. Now our K effective value is equal to, you can write it as 1600 divided by the 3 is K effective. Now I want to calculate the how far distance is moving. Now I am writing delta x is equal to our F divided by the K effective. Our f value is equal to how much? You can see here our f is equal to mg only. M value is 8 kg. I'm writing 8 kg. So 8 into g is equal to 10 divided by the k effect value is 1600 divided by the 3. Now you can see that 0 and 0 get cancelled. This will be getting cancelled 2 times. So finally you can write 3 divided by the 20 meters. But if you see our options, they have given meter as well as centimeters also. Obviously we will not get 1.6. So you can write it as 300 divided by the 20. 300 by divided by the 20, if you write that 15 centimeters you will get. Okay, observe this carefully. You will get the option is B. Correct option is B. Okay, you observe this carefully. I have written that energy method, so that energy of the system is remains constant for the given arrangement. I have used the same thing. Okay, now similar kind of questions are there in Pathfinder only. Other questions how they have asked we can see here. Okay, now you see the question number 35. In the setup shown, a block is pulled on a frictionless floor. The cords and pulleys are ideal and each spring has a stiffness K. The blocks is pulled away from the wall. How far will the block shift? While the pulling force is increased gradually from 0 to F. Now you see here applied force is given F only. Now if you write the what are the tensions are in the each spring. Now I am taking each one is K only. Here T I will write. So if it is T everywhere, here also how much value will be there? T only. So if it is T, here also how much will be there? T. Here also how much value will be there? T. And in this spring we can see K and we can write it as 2T force will be there. So to write the clearly, I am writing again. You can see here this is my pulley. This pulley is connected to the another pulley and this is connected to the two springs and connected to the block. Okay, and this block is having so not is not required actually for us. And here you can see one more spring is there. Okay, this is my arrangement, given arrangement. Okay, I will tell you that applied force is equal to F is applied here. If F is applied, so how much force is actually acting on this? We can see here this whole thing is one spring is there. The whole thing is one spring. I can take this value is T. Okay, that K is there. Here also K, here also K, here also K only. So this is T, and here you can write it as this is what here 2T, and here T tension is there. You can see here T, here also T. Okay, what is pulling force increased from 0 to that value is given. You can see here first spring, second spring, third spring, fourth spring. Okay, I'm using this ones here. T square divided by the 2K plus second spring. T square divided by the 2K plus third spring. T square divided by the 2K plus fourth spring. 2T whole square divided by the 2K is equal to the net force acting on the block. I am making this into the single spring having K effective. Block is connected to this and applied force is F. Here we can see that 2T. Now I can write it as 2T square divided by the 2 into K effective. Now if you see that T square by 2K, T square by 2K, T square by 2K and 4T square. So 4 plus if you write that 3, you will get the 7 T square divided by the sorry, I have written one small mistake here. This is not the T actually, this is a 2T. Here 2T is there. This is 2T. Second spring is there, no? Second spring we can write it as 2T. Okay, you can see here this is a 2T. Why? Because this is T and T, we can write it as 2T. Okay, now we can write it as total value. If you see that T square plus 2T square plus T square plus 2T square, total value is equal to how much? 4. This is actually 4 plus 4 8. 8 plus 9 10. So you can write 10T square divided by the 2K is equal to 4T square. This value also will change here, 3T will come. Okay, we can write 3T. Now you make that changes into 3T. 9T square, this is 3T. Actually here tension on block you can see here, this side is 2t, this side is t is there. Okay, that's why total 3t. I am making correction here, 3t whole square. Okay, 90 square divided by the 2k effective. I can write this value is 2 and 2 get cancel, t square get cancel. I can write the value of k effective value is equal to how much? 10. K effective value is equal to 9k divided by the 10. 9k divided by the 10. Now they are asking how far will the block shift. How far the block will shift means we can write it as delta x is equal to f divided by the k effective. What is the f value? F only. Applied force you can see this is f only divided by k effective, 9k divided by the 10. You can see here in this problem 10f divided by the 9k. This is the fourth option. You can check properly. Just I made here 2t and here this 2t value you can see it properly. Okay, answer is D option. One more question. In this question, again they have given the one more question in the same Pathfinder book. A light frictionless pulley is suspended with the help of a light spring. One end P of a light inextensible thread that passes over the pulley is free and the other end is tied to another light spring that is affixed to the ground at its lower end as shown in the figure. Stiffness of both the springs is 500 Newton per meter. The free end P is H is equal to 10 centimeters. Okay, 10 centimeter above the ground. What minimum pull at the end P will bring it to the ground. So now you can see again I am giving this is the tension T. Here I can write it as 2T. Write it properly so don't get confusion like me earlier in the question. No, just I missed the 2T in this case. Okay, that's why you write properly. And whatever the force is there, I am taking this as a F is the force applied. Okay, you can see that what is the minimum force is there, no, that we need to calculate here. I am writing first spring is there, no, that I am taking. This is my first spring. This is my second spring. I am taking like a t square divided by the 2k plus 2t whole square divided by the 2k is equal to the force acting on the that point is there, no, that we can write like this here. This point is having the tension T and the force is equal to F is there. Okay, I am taking the force is equal to much t square divided by the 2k effective. Okay, now you can write the value is t square plus 4t square. That value is 5t square divided by the 2k is equal to t square divided by the 2k effective. 2 and 2 get cancelled, t square and t square get cancelled. I will get the k effective value is equal to k divided by the 5. As k value you know 500, so you can write the 500 by 5 value is equal to 100 Newton per meter. Okay, now we have the k effective value. I am going to write the what is the force value. You can see force F can be written as k effective into delta x. That delta x in the problem they have given the value is 0.1 meters is 10 centimeter is nothing but 0.1. So you can write the value is 100 into 0.1. You will get the value is 10 Newton. So our required force, a minimum force to pull at the end P to bring this from the certain height 10 centimeter to the ground is equal to 10 Newton. I hope you understand this. Apply this energy method. This energy method will be useful for you to solve the problems from the whatever the oscillation chapter is there. Okay, I hope you